Hello everyone, this is Savannah Beckowski, Project Assistant at the Syracuse University Environmental Finance Center. On behalf of the Environmental Finance Center Network, I'd like to welcome you to our webinar entitled Intermediate Asset Management, Benefits to Mapping Your Assets. To give you an idea of where others on the webinar are tuning in from, we have prepared this map. You can see that we have attendees spread throughout the entire world. Thanks to you all for joining us today. Attendees can receive a certificate of attendance for viewing this webinar. This webinar has not been submitted to licensing agencies for pre-approval of continuing education credits. AWWA recommends that you check with your licensing agency to learn about its criteria, rules, and what you need to do in order to receive your credit for attendance. It is your responsibility to verify this information with your licensing agency. If you need assistance in applying for credit to your licensing agency, please contact Education Services at awwa.org. For attendees who have an AWWA customer record, your certificate will be uploaded within 30 days of this webinar date. For attendees who do not have an AWWA customer record, you will receive an email from AWWA requesting you to create a customer record by a specific date to receive your certificate. If you do not create a customer record, you will not receive a certificate. And this session is one of several webinars conducted by the Environmental Finance Center Network for the Smart Management for Small Water Systems project. The EFCN provides training and technical assistance to small public water systems in all 50 states and 5 territories to help local water systems achieve and maintain compliance with the Safe Drinking Water Act. And here you can see the various centers that make up the Environmental Finance Center Network. You can see that we have centers spread across the entire country. And here you can see the various areas of expertise that the EFCN focuses on. Workshops, trainings, and direct technical assistance are provided on asset management, rate setting and fiscal planning, leadership through decision-making and communication, water loss reduction, energy management planning, accessing infrastructure financing programs, workforce development, water conservation, collaborating with other water systems, resiliency planning, or managing drought. The EFCN also provides a small systems blog where you can learn more about water finance and management on this blog. Blog posts feature lessons learned from our trainings and technical assistance, description of available tools, and small system success stories. You will have the opportunity to subscribe to this blog at the end of the webinar. In addition to workshops, direct technical assistance, and webinars, as part of the Smart Management for Small Water Systems project, we have also created a table that lists the major funding sources for drinking water infrastructure in each state and territory. Here's how you can access those tables. On the EFCN homepage, go to the Resources tab and then click on Funding Sources by State. This will take you to a map of the country. If you click on the state you're interested in, you will find a PDF table of the relevant funding sources for drinking water infrastructure for that state or territory. The table will look like the image on the left-hand side of the slide. For each funding program, it will include the name of the program, a short description, and contact information for someone who works in the program. Now, before I turn the presentation over to our speakers for today, I do have some polling questions to get us started. The first polling question is, what kind of water utility do you represent? Please select from one of the following answers. A for-profit water utility, a local government, either municipal or county level, a non-for-profit cooperative or association, or another water utility such as an authority, school, or hotel, or you're not from a water utility. And we'll leave this poll question open for about another 5 seconds. Getting ready to close this poll in 3, 2, 1. As you can see from the majority of our attendees from a water system, they're coming from a local government utility. And the next polling question we have is, what size water system does your utility operate by number of people served? Please select from one of the following answers. Small or very small, medium, large or very large, or you're not from a water utility. And we'll leave this poll question open for about another 5 seconds. Getting ready to close this poll in 3, 2, 1. And as you can see from attendees that are from a water utility, it looks like we have a pretty split tie between small, medium, or large systems. And the next polling question I have for you is, do you have a system map? Please select from one of the answers. Yes, you do have a system map, and it includes a standard process for necessary revisions and quality control. Yes, a partial map that is electronic. Yes, a full or partial people-based map. No, or you don't know, you're not sure. And we'll leave this poll open for about another 5 seconds. Getting ready to close this poll in 3, 2, 1. And as you can see, a majority of our attendees do have a comprehensive GIS or other electronic map in use for their system. And 2 more polling questions. The next polling question is, does your system have an ongoing mapping program? And please select from one of the following answers. And as a heads up, the QC is an acronym for quality control. So please select from one of the following answers. And we'll leave this poll open for about another 10 seconds. Getting ready to close this poll in 3, 2, 1. As you can see, a majority of our attendees have selected yes, revisions are made, but they are not systematically made. And lastly, our final poll question to get us started is, what trainings have you attended in the past? And you can select all of the answers that are appropriate. And we'll leave this poll open for about another 10 seconds. Getting ready to close this poll in 3, 2, 1. As you can see, the majority of our attendees have picked asset management, rate setting, and fiscal planning. They're all on the board. And at this point, I would like to turn the presentation over to our presenters. Heather and James, are you with us?
We are.
Yes, we're here.
Wonderful. So folks on the line, we have Heather Himmelberger, Director of the Southwest Environmental Finance Center, and we also have James Markham with her. He is a research scientist at the Southwest Environmental Finance Center. Heather and James, welcome and take it away.
Great. I'd like to add my welcome to everybody out there. So good morning or good afternoon, depending on which part of the country you're in, or maybe even good evening for some of you, depending on, we have some people pretty far away. So thank you for joining us today. Today's webinar is about the benefits of mapping your assets, what your utility map can tell you besides where things are. I do want to make one reminder that on your screen, your GoToWebinar screen, there is a chat box. So as we go along, if you want to send us questions throughout the webinar, please do so you don't have to wait until the end to put them in there. We will not take any questions until the end, but you're welcome to type them in as we go along. All right, we're just having a little technical difficulty getting the slides to change. There we go. So why did we ask you about mapping, asset management, capital improvement planning, water loss auditing and control, and rates and fiscal planning? So in that poll question, we asked you which trainings you'd been to. It might make some sense that we were asking about mapping training since we're talking about mapping, but you might wonder why we brought up some of these other topics like asset management or water loss or even rates and fiscal planning. What does that have to do with a map? Well, we ask you about those because maps can tell you so much more than you might be thinking right now. And maps can impact all of those different areas that we talked about, and they have a role to play in just about every part of the daily operations, management, and running of a water utility. Hopefully, by listening to the rest of the webinar today, you'll get some feel for how maps interact with these different processes that you have going on at your utility. So let's start with the basics. So what is a map? So if we're looking at the dictionary definition of a map, so basically a diagrammatic representation of an area of land or sea showing physical features, cities, roads, etc. So essentially it's just putting things where they belong on the earth in some format that you can see. All types of maps can be useful. So you may have a lot of different kinds of maps. You may have a collection of maps. You may have different types of maps. On the screen we have examples of several different kinds of maps. In the bottom left-hand corner we have a hand-drawn map that somebody uses push pins to represent assets and events such as break data. The two maps on the upper right are different versions of as-built and hand-drawn maps where somebody has written notes on one of the maps. It's something that they keep in their truck, pull it out, use it in a hand-drawn fashion, and then write notes on it. And then up in the upper left-hand corner is probably what people consider the gold standard, which would be like a comprehensive GIS map. But it doesn't matter what kind of map you have, just that you have it. So when you think about your own utility, think about what kind of map do you have? And a really important question to ask yourself is, do you find that useful? Are you able to use it? How do you use it? Are the locations on that map accurate? What might be missing from the map? What might you want to add to it? How might you want to change the map to make it more useful to you going forward? We tend to think of maps in narrow terms of the what and the where. So we're going to start our discussion of maps there. So if we think of the question of what, one type of what that many of us in the water and wastewater business deal with is assets. So it's logical to ask ourselves, what assets do we own? If you're in the water utility business, you probably have some collection of tanks, pipes, wells, maybe a surface water treatment plant or another kind of treatment plant, pumps, hydrants, valves, meters, and these various assets are spread throughout your community in different places. So you start by thinking about what is the stuff that makes up your system. And then the next question you might want to think about is what would be helpful to have on a map? So of those assets, which ones would be the most helpful for you to have in some kind of a mapping format? So if you're not feeling like you can take on the whole comprehensive development of a map, you can prioritize what to put on your map. Or if you have a map already and it's not useful to you, you can prioritize how to make that map a better map for you. So think about what would be something that you would want to start with. It could be the things that you operate every day, or it could be those things that you deal with on an emergency basis. So you might have an emergency that happens where there's a hurricane, a tornado, a flood, fire, something like that, and you have to go find particular assets in the event of emergencies. The better located those assets are in a GPS fashion, the more likely you are to find them when the normal visual cues aren't there. So you might have lost the building that, you know, it's 5 feet from this building, but if the building isn't there anymore, you're not going to find that asset. So think about those things that would help you the most, either on your day-to-day operations or in the event of emergency, and that would be a good place to start the map, and then you can build the map out over time from there. And it doesn't matter if it takes you a year, 2 years, 3 years to get your items on the map. If you start slowly, eventually you will get there, you will get things on a map, and you'll be ready to go forward from there.
So we've discussed a little bit about the what. Let's talk a little bit now about the where. Obviously, you're going to want to geolocate where your assets are. Now, that could be physical assets. So, for example, where are your pumps? Where are your meters? That could be boundaries, for example, like pressure zones. It could also be paths. You might want to know what flow paths are in your water flow or in your sewer. There's a lot of different ways you can get this information. You can use GPS, you can use triangulation, and there's a lot of different ways you can display it as well. Pins on a map actually works. You know, there is a wide range of equipment out there. everything from handheld devices that are very inexpensive to phone and tablet apps that you can use on a monthly basis for a small fee. And then there's on the other end, obviously, survey grade equipment. Really what you use is going to depend on your needs and your budgets and your capabilities. Each one of these has pros and cons. Survey grade equipment will tell you down to an inch where something is, but it's also very expensive. You really have to sort of consider what your needs are versus your budget and the experience of the people that you have working for you. If we had unlimited budgets, we could know everything. In this world of limited budgets, obviously we can't pay to know everything. We have to think about what we really need to know. And the most important thing here to consider is that it's really not about the equipment and the software that you're using. It's really about the process. It's very, very important to plan up front. Define your mapping goals and the processes. That's a lot more important than the specific equipment that you use. You want to go out and collect your data, but you need to consider the data sources that are available to you. It's not just field data, the geoposition of a particular hydrant. You're likely to have a lot of other information in other locations, warranty information from vendors, spec equipment from vendors, information in your office related to when things were purchased, when they were installed, when they were last serviced. All of these are pieces of information that you can use in your mapping process. And that's the beauty of mapping the way we're talking about it. It's about combining sources of data, pulling them together, leveraging them against each other to glean new knowledge. And this fourth point is really, really important. The more data sources you combine, the more likely conflicts you're likely to face. You're going to find things that are inconsistent, things that maybe don't make sense. It's important to proof your data on an ongoing basis and review it for errors. Once you put something on a map, look at it, review it, make sure it actually makes sense. And finally, the most important thing is to actually take the data, make the maps, and use them. Several occasions we've talked to systems and asked them about maps, and they say, yeah, we have a map, we had it made a few years ago, and we think it's in the closet. A tool you don't use is worthless. Once you have a map, go out and use it and update it. And it's important to understand that maps can tell you a lot more than what and where. That's what we've been talking about so far. But there's other kinds of information that you can incorporate into maps. Who did something? Did a particular contractor do a particular install? Who's supposed to go turn the valve or flush the hydrant? When did an event happen? Why did it happen? How did it happen? For example, if we're thinking about line breaks, a line break caused by a construction crew digging into a road and hitting one of your pipes is very different than a line break that results from a pressure surge. Those are things that you would want to consider differently. You can even think about how much things cost and incorporate that into your maps. We will talk a little bit about this further on, but what I'm getting at here is all sort of the etc. part of our earlier definition. It's the other information, the metadata, if you will, the data about your data that makes your maps really, really useful. So let's look at an asset here and think about the kinds of information we might want to know about it. Here's a couple of examples. For a hydrant, for example, you might want to know its operational status, what pressure that hydrant runs at. What's the acceptable usage? Is this a hydrant that's used for firefighting? Is it only used for flushing? A small system may only have one type of hydrant, but they may have different uses. What's the condition of that particular asset? Is it part of a flushing program? Is it part of a water testing schedule? Does the color mean anything? Is that locked, and who has the keys? All of these are sort of important pieces of information. And when you're looking at an asset, some of this stuff might seem sort of intuitive, but you have to remember that a lot of this information you're not going to be able to figure out by looking at an asset. And oftentimes when you're making inquiries about an asset, you're not actually looking at it. So these are things to think about in terms of the types of information that you would attach to specific assets. Now, of course, the kinds of information that you're going to consider is going to vary from asset to asset, and that's something to consider. But we also want to think about events that we can map and log. And you probably have this kind of information in work order systems or in other locations. And for example, break data is something that can help you with all sorts of issues. It can help you with real water loss. So for example, if you're doing auditing, knowing when your breaks happened and how long they ran can help you figure out how much water was lost and potentially validate some of the audit information that you get out of an AWWA water audit. It can help you with capital improvement planning and prioritizing pipe replacement. You'll see some examples of those a little bit later. They can also help you estimate the condition and useful life of your assets. Particularly with pipe, it's in the ground. It's hard to see. You'll see as we go through this that using your pipe break data can actually help you get a handle on how your pipe is performing and how long it's likely to last. So as you're going through these, think about the other types of data that you consider for your different assets. You know, mapping meters might be an important thing to you. You know, that's where you're going to get additional information for that. Well, maybe from your billing software. And as you're discussing this inside your organization, think about the value that this might provide for you. One system that we worked with recently didn't really see the value of mapping their customer meters, and their statement was something to the effect of, well, what's the point? We already know where our meters are. We did that mapping and determined that there were actually a lot of meters out in the field on active accounts that were not in their billing system, and that there were some meters that were in their billing system that were assigned to the wrong customers. So there you had issues of revenue being lost because meters weren't in the billing system. You had potential misbilling issues because different meters were attached to the wrong customers. All things to think about when you're going through and creating a mapping process. So what we've been talking about here is leveraging data from a lot of different sources for your maps. I'm going to give you a specific example so that we can sort of take this out of the theoretical realm of a system that we worked with here recently. They actually had some maps. They had a physical map book. Actually, each one of their operators had a copy of this, and as you can see from the picture here, there were notes written by different people about the quality of the assets that were in the ground, the types of pipe. So they already were sort of one step down the road. But what we noticed when we talked to different operators was that much of this information was inconsistent, and sort of the general knowledge or the apparent knowledge about the system varied from person to person. Another piece of data that this system had was a call log. They had recently gotten a new city manager. He's a very proactive person and decided he wanted to track some of this, and so he set up a call log. And by the time we interacted with them, they had about 18 months worth of data covering leaks of various kinds and sewer issues in an Excel spreadsheet. And this is great data to have. It's got address information, it's got report times, it's got some details about the issues themselves, but you can't really visualize this. You can do some sorting, but you can't really visualize it. And as we went through the process, what we realized also was they only had part of the data because they were only keeping this log during business hours. So there was additional data that their emergency dispatch folks actually had been keeping. Another issue was that despite the fact that this information was in a digital format, they primarily used it in its printed form. They would print these spreadsheets out and sort of use them as a checklist, but still good data. What we did is we took all of these different data sources and combined them in a GIS map. So what you're looking at here is the water distribution system for part of the town, and the colored dots on there represent the breaks. We looked at the time information that we had, report time and repair time, and did some level of service analysis. So anything on there that's green was fixed within a week, anything that's yellow was fixed within 2, and anything that was red took more than 2 weeks to fix. So by taking a couple of different pieces of information, we now have a bit better picture of what's going on. Sort of as a general overview, we can see most of these spots are green and yellow, so we're getting our leaks fixed fairly quickly. But we can also notice that there are some patterns that have developed. These 2 circled areas show an area of areas of repetitive leaks. This is something that hadn't really been brought to anyone's attention before. What we also noticed is through our conversations, this area circled in red had been designated as a sort of problem area by the operators. And when we looked at the data from the sources that we had, that didn't seem to jive with what the operators were telling us. So here's a close-up. We've got a set of streets where all the pipe was put in at about the same time, and we've only got 4 leaks. So we kind of went back to the drawing board and thought, well, what more information could we potentially leverage to get a clearer picture? And what we realized in this case was that the streets hadn't been repaved in 20 years. So we had a physical record of every repair that had been made available to us. So we went out and geocoded all of those breaks. And what you're looking at here is a screenshot of an inexpensive phone app that we used in combination with a GNSS receiver to geotag those assets. And what we found when we combined that information with our prior information was this. This is the same area, but now we've got 20 years of breaks in there instead of just 18 months. And you can see the blue and red and green dots are still there that show you the breaks that happened recently. But it also shows you that some of this pipe has been breaking very, very frequently. You've got pieces up at the top with 10 and 11 breaks over that period. It also shows that some of the pipe has never broken at all. And another thing that jumped out at us was this area right here, which did not even show up in our initial data analysis, but has historically been a problem. Now this of course begs the question, has this problem stabilized itself? We don't know, but this is a way for us to sort of see that information and analyze it. So we've been talking about leveraging data for maps. You can do it the other way around as well, leveraging maps for data. So what you're looking at here is a GIS map from a different system. They had very, very robust GIS mapping that showed all of their assets and where they were, but it only really told part of the story. This system was very interested in determining whether they were investing enough money in their O&M and capital replacement budgets, and to figure that out, they had to have a decent valuation of their system assets, which they did not have. So what they were able to do is take the asset information out of GIS and combine it with a tool that we gave them to sort of develop a cost structure. Now this particular tool is a simple spreadsheet that does some calculations. It's based on some national pricing, and it gives you a low, high, and median valuation. So by leveraging their existing GIS information with another tool, they were able to come up with ballpark figures for their asset values that they could then further refine. And if they wanted, they could take this information, build it back into the GIS system so that they could have much more granular data. Instead of knowing how much the entire system is worth, how much might it cost to replace a given piece of pipe or sewer. What we're all talking about here is really a process. And everybody in your system has some kind of information, and that might be in their heads, that might be in notebooks, on paper maps, in their trucks. But what we want to do is take that information and document it in such a way that it can be used by other people in the organization. And this next step is really important. You want to digitize that data. If you've got it in some sort of electronic format, whether that's a computer spreadsheet or a shapefile for GIS or some combination, you can use that data and combine it with others to do analysis and visualization. People are really good at pattern recognition and looking at maps of both physical assets and events that happen over time can teach you a whole lot about your system. And there's a lot of ways to do this. The appropriate tool is really going to depend on the size of your system. A small system with a couple of hundred connections can probably get away with a paper map with push pins in it, whereas a larger system might want a GIS system blown out. Which you choose really depends on you, and you can also think in terms of starting small and moving toward a larger and better mapping program. But the end result of all of this is that by doing mapping and collecting this data and combining knowledge, you end up knowing more than you did as individuals. And that's what we're really talking about here. Leverage data gives you a whole that is much more valuable than the individual parts. And by harnessing collective knowledge, you're able to make much better data-driven decisions.
So we've been talking about some examples of how maps can help you. So we're going to go through a couple more examples and looking specifically at maps and how they can help you with your workforce. So one of the ways that can help you is to save operator time. Operators are very busy, have a lot on their plates. So if you're spending a lot of time looking for assets, you're not having time for doing some of the other tasks that you might want to accomplish. Here's a picture of some folks that work for a relatively small utility, a couple of operators and one of our crew members in the process of trying to make a map. And they wanted to share what the operator who was going to be retiring soon knew with the person who was going to be taking over. In the process of trying to identify all their assets, they really had a lot of trouble locating this one particular valve in the system. And it actually took them 2 days and 12 hours to find this particular valve. Now, in the future, this valve is going to be easily identified through GPS coordinates, and it will probably never take them more than about 10 or 15 minutes to ever find this valve again. This particular utility has experiences a lot of snow events and other things that make it difficult to find their assets. And routinely, they might spend 2, 3, 4 hours looking for an asset during the week. So if you just think about if that happens to you, where you're looking for assets, even if you spend an extra hour or two per week looking for an asset, that's 52 to 100 hours a year that you're spending looking for assets that you could spend doing something else. And every one of those hours is also associated with a cost for the utility crew member or a truck or other equipment you might be using. So having an ability to save operator time through better locational data is one way that you can really help out your operators. Another thing that can help operators is consolidating your information sources. So we talked about before that operators may have a whole bunch of different kinds of maps and different kinds of information, and it's probably in different places. So some of it might be in office, some of it might be in your truck, some of it might be on a computer, and trying to have access to all that information at the same time could be really valuable. So here's a picture of just a paper as-built drawing that initially was how this utility located assets. They would pull out their paper as-built map, and you can see it's actually got some damage, a burn mark up in the corner, and it's kind of dirty. This map could be digitized and added to the GIS map, so the same hydrant that's circled on the as-built drawing is also circled on the GIS map, and then you can also tie a picture of the asset to the map as well. So here we have the picture of the particular asset, and you can see that they're taking positions of the valve, and they've even painted the valve to make it easier to find. So all this information can be tied together so that if an operator clicks on the asset in the map, and it can be either done in the field or in the office, you can get all this other information, and there's really no limit to how much information you can tie to the map. So it can be all kinds of things that you might want to have access to. Another way to help operators is to allow them to share their hard-earned experiences with each other. So here's an example of a knowledge management program we were working on with this utility that was trying to share information from the operator who'd been there for quite some time with the operator who will be taking over the system. Where he's standing, you can see that there are two valves. They're colored in red. One is beside him and one is in front of him. These valves are very different and have very different impact on the system. So the one beside him just isolates a fire hydrant. The one in front of him, if opened, would actually drain their storage tank in a matter of minutes, which would be a hugely problematic thing to happen. So you can imagine if somebody is going out and working on that hydrant, tries to isolate it so they shut the valve, and then when they go to turn it back on, they don't notice that there's two, and they open the wrong valve to put the hydrant back in the system, and all of a sudden the tank is drained. In this particular case, there's a video of the operator explaining what's going to happen if you open that valve, and the new operator can click on a link, get the video, the operator will explain, don't open this valve because you're going to have this problem. So those types of things that the very experienced operators know through trial and error or through the years they put in can be shared through mapping so that you don't have to have your next operator go through that hard-earned experience to figure things out. Here's another example, again, of a video that was taken as part of this utility mapping exercise. In this particular case, there's actually two lines on the street. One of them connects the houses through service lines and meters. The other line just equalizes pressure in the neighborhood. They don't want any taps made to the line that equalizes pressure. So he's trying to share information in this particular video to let the operators know that there is a line in the street that is not meant to be tapped and is only there for the purpose of equalizing pressure. That's very important information to know for a couple of different purposes. If you're ever digging in the street and there's this extra line, you might want to know that it's there because maybe that's not the norm. And you want to know, oh, well, this isn't an abandoned line. This is there for the equalization purposes. Or you want to make sure that when you tie in, you're actually tying to the proper line instead of the incorrect line. So it's very important to know this information. And again, it's a way to pass information from one operator to another. So as they're looking at the map, they can click an asset, pull up the video, and hear the explanation. We've shown you a lot of examples that are GIS examples. The picture you see now, we wanted to throw in there to let you know that it does not have to be GIS. This is actually a map that was done through an inexpensive app that you can use on a smartphone or a tablet. So it has the appearance of a GIS map, but it's not a expensive, highly difficult to use type mapping scenario. And you can see that there's quite a bit of data that you can collect on assets. There's many, many more. This is customizable to be however you want, but you can have information about the asset name, you can have asset IDs, you can have addresses, photos, operational status, size, all kinds of things. And this particular map is from a system that's still going through the mapping exercise. And you can see on the far left, there's a status of the mapping activity. So the different colored dots represent assets and the different state they're in. Some of the asset data collection is ongoing, some of it is complete. And through this mapping app, you can actually have a whole process. As James mentioned, the planning process, this can be used to plan out how you're going to do things going forward. Maps can also help you plan for the future. So here's an example of a large utility that was really interested in looking at how they can determine what pipes to replace in the future. They have a lot of cast iron pipe. A lot of it was put in at the same time. So if you just use age as your proxy for condition, you're not going to get very far because you're going to have to replace a whole bunch of lines or randomly choose which lines to replace because you don't really know any more about condition than the age of the asset. So on the far left of your screen, you see the only mapping that existed prior to us working with them, and that was mapping that was digitized as-built drawings. They were actually pretty dark and hard to read. We took those and printed them on bigger size paper, which you see in the middle there, and we color-coded the pipes based on the size and type of pipe. And you could actually use a map like that, would be fairly useful to you. It looks like we have lost the presentation. Let me see if we can. Savannah, can you see how we can get our screen? Okay. Okay. Looks like we're back now. Sorry about that. So again, in the middle, you could actually use that map. If you didn't have the ability to go to GIS, I mean, you could make use of the maps in the middle as a temporary measure or even as a permanent measure, depending on how big your utility is. They also had data in the bottom. You'll see a screenshot of an asset access database that they had created to store break data. They had about 15 years worth of break data. They couldn't really tell what was going on. We put that data into a GIS format, so we combined all the data sets they had, and you can see up in the far right hand corner all the dots for all the breaks that they had in their program, in their access database. There was a particular portion of the utility that they were concerned about, and that's what you see highlighted on the screen. So we focused our efforts on this particular area because they were worried about how that area might be performing, and this is where they thought they might have to replace pipe. What you'll notice is they were, some of the analysis told us that they were a little bit off because this particular area actually had fewer breaks on a per mile basis than many of the rest of the pipes in the system. But there was one very interesting portion of the system where there's a lot more breaks than the rest of the system. This would give you some opportunity to really dig into a little bit more why there was more breaks in this particular section of that neighborhood. Did it have to do with pipe type, soils, construction materials, construction techniques, etc.? I mean, that would be something you could do a little more investigation, and then that would inform you in the future changes that you might want to make. This can also be used for their capital improvement planning process, where the pipes with the most breaks, where there's 2 of them with 23 and 13, you would probably do those first, and then the 7s and 8s and 9s you would do in the middle, and then 5, 6, and 7s next, and then finally you can put off the 1s and the 2s and the 0s for quite a while. So this can be used to help you formulate a capital improvement plan. Maps can also help you save money, and in some cases lots of it. Here's an example of a small utility that actually believed that their pipe was in such bad shape that they would have to replace all of it. And so they were looking at having to spend $5 or service lines, and the yellowy colored dots were where somebody was digging the pipe up. The bottom line is it turns out that their vision of needing to replace all the pipe was incorrect. Their pipe really wasn't in bad shape. They had one particular problem with not restraining a joint, but for the most part the pipe was fine. They were able to do a project that included loop lines and some other things that ended up helping them and making it so that they only had to do a very small $50,000 project instead of a $5 million project. So they saved almost $5 million by doing a map and looking at a more data-driven answer. Our next example is a large utility that was worried about their mainline breaks and how they were happening. We plotted a 15-year worth of break data on the map and determined that most of the breaks were occurring in cast iron and steel pipe, and you see yellow dots for the cast iron breaks, red dots for the steel breaks. They look roughly even, but if you look at the system as a whole, the bluish color pipe is cast iron pipe and the red colored pipe is steel. It turns out that steel represented 5% of the system and cast iron about 50%, but the breaks on the steel pipes were 50% of the breaks. So that was a major problem for the utility, that, a major finding that 5% of the pipe is causing 50% of the problem. They wanted to change how they were addressing that, so they started an asset management program, and one piece of that was trying to use a more data-driven process to replace steel pipe. So really looking at the probability of failure and the consequence of failure and replacing the highest priority pieces of pipe first. What you see here is a map from before they started their asset management plan till the end, or till more current times, and the constant drop in lines and breaks per 100 miles of pipe by using a better process to replace pipe. From FY11 to FY16, there's a 45% reduction in the break rate and the associated costs with the breaks. So that's a pretty major finding, and it means a lot of money that they're saving, because every break they're not fixing is money that they don't have to spend and can spend in a different area of their system. So if we go back to our analysis, initially there were operators in that system that had information, but it was really in the heads of just individuals. It wasn't collected. The documentation was on paper work orders when we started this study. We had to take those paperwork orders, search all of those records for mainline breaks because they were mixed in with everything else that was on the work orders, and create a database. Using that database and a GIS map, we were able to visualize the data and analyze what was going on, looking for trends. And by the end, the system knew a lot more. They had gained knowledge about the problem. They improved their decision making, which resulted in a greater system integrity and significant cost savings.
So those are some specific examples of what mapping can actually do for you and kind of the benefits of doing that. But we wanted to sort of go over a few highlights that you will hopefully have as takeaways here. Mapping is all about the process. All of these examples involve significant amounts of upfront planning. And so that is kind of a key thing. Think about what you're trying to do, what sort of questions you're trying to answer, figure out how you want to go about doing that before you go out and start collecting your field data. Remember that in addition to field data, there are lots of other data sources for you to look at. One of the things we noticed in one of our projects was customers often had information about events that had happened that the operators didn't, because customers had been there for much longer than some of the operators had. Easiest way to get information from a customer: walk around in the street in a yellow vest. People will come out and talk to you. Mapping, the way we've been talking about it, is all about combining disparate data and making something more about it. So, once you've got your different data sources, you need to leverage them against each other. Remember to be consistent about your data collection, and it's really important to review that information and proof it and compare it to each other. You will inevitably find that there are conflicts between different data sources, and that's a good thing, because by figuring out what the issues are, you actually learn more about your system. And I'm going to show you a couple of concrete examples from these examples that we've been showing you as we've been going through this process. Here's an example of data proofing. Now, this is the system we talked about before, where we found that the pavement cuts gave us some more information. Some of the base data that we had that we used to create the initial GIS map was probably wrong. You can see that circled area indicates that that's 2-inch cast iron pipe, and looking at all the pipe around it and knowing how systems are constructed led us to question whether that was actually true, and it turns out it's not. This is an error that crept in. This was incorrect information that was in the existing files that we were able to correct and actually even see by going through the mapping process. In this database that we looked at before, we discovered some operational issues, and this is a neat thing about mapping, is that it can help you in a lot of different ways. As we were parsing through this data, what we realized is there was work being done that wasn't being documented in any sort of a work order, or if it was, that information wasn't being correctly recorded. We found that they had about 35 different types of break codes, but when we sat down with them, we realized that they were being used inconsistently, and there were 4 or 5 codes where nobody actually knew what they meant. And finally, in this particular example, we've got a comment section here that is being used inconsistently by staff. Some people are putting in their initials to let the utility know who was doing the work. Some people are using it for comments, and some people are using it as a combination of the two. So this is sort of a workflow, work process issue that didn't come to light until we actually started parsing this data for a mapping project. Ultimately, the big takeaway should be, make your maps, improve them over time, and use them. The best way to find out whether a tool is good enough for you is to use it. If it turns out that the tool is not doing what you need, you can always change how you collect information and what you do with it. Remember, your maps should not be static. They're living documents. As you get new information, you can incorporate that into maps, and you really need to think about how you're going to update your maps. Develop standard operating procedures to handle the data flow, to determine who's going to collect the data, how it's going to be proofed, how it's going to be included in the map, because you can start out with a great map. If you don't keep a good handle on how you're updating it, you can actually end up doing the opposite of improving it. And remember, information of all kinds can be used for mapping. It's much more than just the physical locations of specific assets. You can put in meter routes, sample locations, schedules, pressure zones, shutoff sequences for repairs. Could be very important to know which way a valve needs to be turned, particularly if you're a system that has valves that work both ways. You might want to have information about how fast valves should be turned off so that you don't have pressure surges and water hammer. And this is really the power of mapping in general and GIS in specific, is that you can take all of this kind of information, glom it together, and develop something much bigger than the sum of the parts. Some final considerations to think about if you're beginning to develop a mapping program or thinking about expanding it and looking at different data sources. Remember that some of the data that you're going to use may not have been generated for mapping. It might be great for its intended purpose, but there's going to be some issues, inaccuracies, and concerns. So for example, if you're mapping your meters, you might start off with an address. An address can be turned into a geoposition latitude and longitude. It's a little bit inaccurate to start with, but it's a good starting place. And that's the key takeaway here, is that over time you can change how you collect data, how you use it, and what types of data you collect. And finally, mapping can seem like a daunting task. It's really not if you start small. Don't let what you can't do stop you from doing what you can. Figure out what kinds of questions you want to answer, and figure out how you can go about answering them. Remember, you can eat an entire elephant if you do it a bite at a time. So with that, we're going to move to Dawn, who has been monitoring questions, and see if we have any that we can answer for you on the fly here. And remember, we may not be able to get to every question, but we are going to create a document after this where we try to answer all of the questions on paper, and we will be sending that out to all of the participants today. And here's our contact information in case you have questions for us directly. So we'll hand this over to Dawn and see what we can do.
Great, thanks, James. We do have lots of questions that came in. The largest majority of the questions that came in were, can you tell us the name of the app? Can you tell me about the GPS? What data was collected, or the resolution for the data that was collected? Do you have suggestions for apps? So I would say that was the majority of people would like to know more about the software and the technology that we're using, and the recommendations that we may or may not be able to give.
So let me put one preface, and we will be glad to tell you what we use, but the preface is we're not in any way, shape, or form recommending or saying that this is the only way to do it. It's just the way we have chosen to do it. So we purposely didn't have the specific name of the apps and devices in the presentation to prevent from giving the impression that we're telling you to use one particular approach. But we will share with you what we used, but again, it shouldn't be taken as a recommendation, but rather just this is the direction we chose to go in looking at what was important to us, like relatively inexpensive but reasonable accuracy. So James, why don't you tell them about the specific apps that we chose to use?
Yeah, so we actually did a lot of the data collection using a combination of an application called Fulcrum. You can go to their website. It's fulcrumapp.com. It's a very inexpensive app. You can sign up on a monthly basis. It's $25 a month per user, I believe. And you can use that with just a cell phone. It's something a lot of folks probably don't realize, that there is a small GPS receiver in most smartphones. That's how Google Mapping uses you, or locates you. We used a small geolocator called a Bad Elf. There are a lot of other systems that you can use for that. We use primarily Esri ArcGIS for the GIS mapping, but there are free open source GIS programs like QGIS, And Google Maps is also a very good platform, and that actually underlies a lot of these other platforms. And as Heather said, there was a reason we left all of those out, because those are apps that we're familiar with and tools that we're familiar with, but there are a lot of other ones that are just as good and maybe better for your given situation. It's really sort of an individual decision.
And the Bad Elf device that James was talking about, we spent about $500 or $600 a piece for those devices. There's a cheaper version that's not quite as accurate. The one that we picked in general is about plus or minus 3 meters. We found that if we left the device in place for a longer period of time, we could get really good accuracy. So there comes to be a time issue that, leaving it in place for a couple of minutes gave us way better locational accuracy, but then it's going to take you longer to get the data. So that's another area where you can decide, how close is close enough. If you want it to be a better accuracy, leaving the device in place so that it would capture more satellites and then give you a slightly better accuracy, is that worth it? Or do you just want to put it down quickly, get the accuracy to be a little bit less accurate than, below 3 feet, 3 meters. So that's kind of a choice that you can make, is how accurate you want it. And then some of the devices like Fulcrum allowed you to move the point. If you could see an underlying Google Earth image where you could actually see the meter or the hydrant or the asset you're trying to map, and the accuracy of your GPS was not quite what you wanted, you could actually slide the point and make it, right on top of the Google Earth image. So there's different ways to impact the accuracy, but in general, we were about plus or minus 3 meters.
3 feet, actually.
3 feet, sorry, in the accuracy department. So, you can do better than that and spend more money. You can do worse than that and spend less money. It just depends on how important the, really getting close to that asset is, or if you just want to get relatively close and use visual cues or metal detectors or whatever to get you the rest of the way.
Yeah, and one advantage to using something like Fulcrum or Esri's Collector or a similar kind of app is that you can, as Heather indicated earlier, you can customize the types of data that you're collecting before you go out into the field. So those data collection fields that you saw, those were all applications that we had built ahead of time so that we could pre-populate some information in the office and then collect some data out in the field. So there is, a great advantage to the planning part of that, and using an app that allows you to sort of do multiple things at the same time rather than maybe just collect a data point.
Don, we probably have time for maybe one more quick one.
So they would like some clarification on the apps and the software or the hardware. So Bad Elf is bad, B-A-D, Elf, E-L-F.
Yes.
Fulcrum is F-U-L-C-R-U-M. Is that correct, James?
Yes, and the website is actually fulcrumapp.com.
And then Esri, clarifications on all of the terminology that we're using. We have lots of other questions pouring in, so I know we're not going to get to them all, so I just wanted to remind everyone we will address them. We will email you, and we will make the presentation available. Give us about 2 weeks, and I think we do have some polling questions at the very end here, so we can turn it back over. So thank you guys so much.
Thank you, Dawn. All right, so to quickly wrap up, I do have 2 remaining polling questions for folks. The last of our polling questions is, are you interested in subscribing to the Environmental Finance Center blog? If you would like to sign up for the blog but do not have the opportunity to submit your polling answer today, you can sign up for the blog on the efcnetwork.org website. And getting ready to close this poll in 3, 2, 1. And lastly, our last poll question is, if you are a small water system of 10,000 or fewer people served, are you interested in receiving in-depth technical assistance? If you're unsure about technical assistance or do not have the opportunity to submit your polling answer today, please review the technical assistance form on our efcnetwork.org website. And we'll leave this poll open for another 5 seconds. Getting ready to close in 3, 2, 1. And lastly, in the chat box, there is a survey link coming out to you. If you could just give us 5 minutes of your day to let us know how you thought today's session went, that would be wonderful. I would like to thank Heather and James for providing their expertise on asset management, and also would like to thank Dawn for moderating today's question and answer segment. Thanks to all the attendees who have joined us today. And Heather and James, I will throw it back to you for last remaining closing comments.
We wanted to, again, thank everybody for tuning in today. Clearly, this was a topic that a lot of people found of interest. We will try to have some additional webinars in the future that relate to mapping. Again, if you have questions that you didn't have a chance to type into the chat box, you have our contact information. You're always welcome to reach out to us via email and ask us your questions. We wish you good luck in mapping your utilities. And, please share any of your stories with us as you go along. If you're having difficulties during the mapping process, or you want to share something that happened that went well, we're always collecting good stories. So please feel free to share those with us. We'd love to hear them. And again, we thank you so much for spending, part of your day with us.